You know how interacting with foundation models like ChatGPT or Gemini feels a bit like magic? That probabilistic nature, the fact that they're essentially guessing the next word, is what makes them so creative and honestly just a blast to talk to. But if you're an engineer trying to build reliable software, it is literally what keeps you up at night. It causes wild inconsistencies and those infamous hallucinations where your polite customer service bot suddenly turns into, I don't know, a rogue, nonsensical poet. Transforming that probabilistic magic into a rock-solid, production-ready product is incredibly tough. But hey, that is exactly the challenge we're tackling in today's Explainer.
And we aren't doing it alone. We're leaning on the absolute best in the business. Just listen to this. Drawing on her deep expertise, AI engineering serves as a comprehensive and holistic guide, masterfully detailing everything required to design and deploy generative AI applications in production. That's from Luke Metz, who, by the way, is a co-creator of ChatGPT, speaking with genuine awe about the incredible work of machine learning systems expert Chip Hewen.
So today's Explainer is a highly detailed, foundational masterclass. We're distilling her landmark book, AI Engineering, just for you. We're talking about a massive 150,000-word roadmap that covers the absolute end-to-end process of adapting foundation models for real-world problems. We're going to condense her expertise, covering everything from model architectures and fine-tuning to vector databases and system architecture. The goal here? To help you stop wrestling with fragile demos and start engineering robust, scalable systems. Okay, let's dive into this. Here is our roadmap. First, we've got the AI engineering shift. Then, foundations of model responses. Next, beyond prompt engineering. After that, context, RAG, and agents. Then we'll map out the modern AI stack, and finally, we wrap up with making AI systematic. Section 1. The AI engineering shift. Moving from just playing around with chatbots to real engineering means asking the right questions before you write a single line of code.
According to Chip Hewen's introduction, there are essential questions every AI engineer absolutely must answer. Notice the very first one. Should I build this AI application? Not can I, but should I? Skipping this step is actually the #1 reason enterprise AI projects fail in production. People build things that don't even need AI. From there, you immediately hit evaluation. How do you even measure success? You've got to understand the root cause of hallucinations to mitigate them, know the best practices for prompt engineering, understand why retrieval-augmented generation, or RAG, actually works, and definitively answer, what's an agent? This is your foundation right here.
Section 2, Foundations of Model Responses. Once you've asked those big questions, what actually dictates how an AI responds to a query? Well, outside of basic settings like temperature, response quality comes down to 3 progressive dependencies. Step 1, the instructions. This is how you explicitly command the model to behave. Step 2, the context. This is the specific data and background info you feed the model so it doesn't have to guess. And step 3, the underlying foundation model itself. Its architecture, its parameters, its training data. Think of these 3 things as your progressive toolset. You start by tweaking your instructions, then you bulk up the context, and if it's still not reliable enough for what you need, you go deep and optimize the model itself. Section 3, Beyond Prompt Engineering. And that progression brings us to a critical realization. Prompt engineering is a fantastic skill, but relying on it alone just isn't enough for the big leagues. You really have to understand when to use which tool. Hewen uses a brilliant metaphor here, dividing techniques into bandages versus intensive treatments. Things like prompting, post-processing outputs, or using test-time compute, where you just generate a bunch of outputs until one works. Those are bandages. They're great if the model's already pretty good at the task and just needs a tiny nudge. But for deep structural requirements, you need intensive treatments, like constrained sampling or actually fine-tuning the model. Fine-tuning isn't just asking the model nicely to do something. It's literally altering the model's neural weights to bake in domain-specific knowledge that a prompt simply cannot achieve. So what does constrained sampling look like in practice? Well, when you need absolute predictability, it's a total game changer. Imagine strictly forcing the model to only output a specific set of options, like red, blue, or green. It literally cannot say yellow. Or you can constrain the output to a regular expression, forcing it to only spit out digits. When you're building a system where the AI feeds directly into another rigid software function or database, this kind of intensive treatment isn't just a nice-to-have. It is strictly required to stop your whole system from crashing. Section 4, Context, RAG, and Agents. Now we transition from changing the model's instructions to giving the model a memory and the autonomy to act on it. Let's talk about Retrieval Augmented Generation, or RAG. It's basically using a database to supplement your instructions, giving the model relevant context exactly when it needs it. Mechanically, how does this actually work? Instead of relying on the model's static training data, you convert your enterprise data into embeddings, which are just mathematical representations of text, and store them in a vector database. When a user asks a question, the system does a semantic search, grabs the most relevant chunks of data, and injects them right into the prompt. It's the industry standard way to ground a model in reality and squash those hallucinations we talked about earlier. But what if you want the system to actually do things beyond just generating text? Enter the agent. The tech industry throws this word around constantly, but Chapter 5 cuts right through the hype with a sharp, foundational definition. An agent is anything that can perceive its environment and act upon that environment. It's not just a chatbot. It's a system that can search the live web, read your calendar, and autonomously book a meeting for you. It's defined entirely by the environment it operates in and the specific tools it's allowed to use. Section 5, the modern AI stack. We've looked at micro techniques like RAG and agents, so let's zoom out to see how this all fits into a macro enterprise architecture.
Here is the modern AI stack, straight from the book's architectural breakdown. You need to know exactly where your work fits in. At the bottom, you have infrastructure. That's your heavy ML engineering and raw server compute. In the middle is model development, focusing heavily on inference optimization. This is where engineers use really cool tricks like quantization, which reduces the precision of the model's weights, and dynamic batching to make running these massive models super fast and cost-effective. Finally, at the top is application development. This is where you're building the AI interface, running evaluations, doing prompt engineering, and setting up those RAG pipelines.
Within that application development layer, you have a robust 5-step orchestration pipeline. Step 1, enhance the context with your vector database RAG setup. Step 2, put in guardrails to defend against toxic outputs and prompt injections. Step 3, add a model router and gateway to dynamically pick the absolute best, most cost-effective model for a specific query. Step 4, reduce latency with caches. Semantic caches are wild because they don't just match exact text, they match the meaning of a question. If two users ask the exact same thing in slightly different ways, the cache catches it and slashes your API costs. And finally, Step 5, add agent patterns for complex planning or tool use. Section 6, making AI systematic. This is where we bring it all together to transform that unpredictable magic into a reliable, predictable system. UN dedicates entire chapters to this because it's absolutely paramount. The very first step towards systematic AI engineering is establishing a solid evaluation pipeline. Honestly, evaluation is arguably the hardest challenge in AI engineering right now. You can't improve what you can't measure. You have to build a golden dataset of highly vetted questions and perfect answers to test against. You might even use something called LLM as a judge, where a massive, super smart model grades the output of your smaller production model. Because without a reliable way to systematically measure performance, you'll never know if a new prompt, a new RAG setup, or a fine-tuned model is actually an improvement or just broken in a new and exciting way. So we've covered the foundational mindset shift, the tools ranging from prompting to fine-tuning, context construction with vector databases, and the entire modern orchestration stack. You now have the roadmaps to move beyond treating AI as a magical black box and start treating it as a rigorous engineering discipline. So my question to you is this: are you going to keep building fragile demos, or are you ready to take this systematic framework and engineer an application that actually scales?